Welcome to the GOTO Podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
So, welcome to another GOTO Book Club. I'm Andrew Harmel-Law, and this week we've got the three authors of Effect-Oriented Programming with us. So just a little bit about me, because it's kind of maybe introduces how I know Bill, James, and Bruce. So there is an open space conference up in Crested Butte in Colorado, where I think all three of you live, right? I'm guessing you all live there now, because you were all sitting on the same here. So it's an open space conference, so everyone should definitely attend it, because it's the best open space conference I've ever been to. But I first met Bill and James and Bruce at this open space conference. And one of the cool things is that at that conference, I was introduced to effect-oriented programming, and I'm kind of interested to find out, this might be one of my questions, how lots of those conversations and those sessions led to this thing. But first, I should let you introduce yourself. So do you want to go first, Bill? Just tell everybody who you are and how you ended up here.
I am Bill Frasure. I have known these guys for about 10 years now, mainly just as friends, but eventually we found our way into finding a project we were all interested in. I worked at Zyverge for a few years, which is the company behind ZIO, which is the effect system of choice for our book, which we'll get more into later. I've just slowly become more and more interested in functional programming via Scala or whatever language might come in the future. And I'm definitely the most junior of the authors here. I've got
the most experienced in ZIO.
Yeah, definitely.
It's a good trade-off.
The one small pond that maybe I have the deeper experience in.
Cool. Cheers, Bill. Bruce, do you want to go next?
Sure. Bruce Eckel. I've mostly written books. Sometimes I do consulting. Yeah, there's some of the books back here. I've been doing this for a long time. I've mostly focused on languages in the past. I'm trying to broaden my perspective now. And also conference organization is something I've been involved with for a long time. The upcoming Winter Tech Forum is the first week of March. Here in Crested Butte, which is a ski town, and
we'll have to get Andrew back.
Yes, which we've been wanting to get Andrew to come back here for every year. He's going, maybe I can come, and then something happens and you can't. Yeah, that's me.
Nice. Yeah, thanks, James. Sorry, Bill. I should stop reading the names at the bottom. The names are the wrong order on the screen. And James, sorry, do you want to introduce yourself quickly?
We'll line the names on the screen.
No, the names should be aligned with it's confusing.
Yes, right. Yes, I'm James Ward. I work on agentic AI stuff at AWS. And Bruce and I have a podcast together called Happy Path Programming. So that's a fun little hobby. And
we wrote a book together.
We wrote a book long ago.
Immediately.
It's up here on the shelf.
Yeah,
We've hidden it behind this one.
Yeah.
That was on dead technology.
Yeah, well, it was dead as soon as the book got published.
Yeah. So I think one of the things, Andrew, you'd said that you started exploring effects up here at one of the conferences we did up here. And that was my first experience with effects and Scala ZIO. Actually, that's where I first started getting into effects was here at one of our conferences. And so it was early days for ZIO. I think it had just been announced as, the first, pre-release of it. And so we spent a couple of days during the conference just diving in, trying to learn it. And it took us a little while to kind of wrap our heads around what in the world is this and why do we need it and why is it better? And so I think our journeys.
It's taken me all of those years to try and figure out that.
we're still working on it.
So that leads perfectly on into my first question. So, because the book is, and this is a thing I've noticed kind of like in more and more books recently, the book is not very thick, but it's obviously taken you like a number of years to figure out, right? And having been someone who's written a book which is far too long and could potentially be a lot thinner, do you maybe want to just quickly explain to us a little bit about that journey? Because it's very, and I mean this in the best way, it's super terse, it's very focused, right?
Yeah, well, I think there's a few motivating factors, one of which is just how much knowledge and background seem to be required to get into functional programming and effects in particular. And it was always these very intimidating texts with all sorts of assumed knowledge about, you must be this smart to read this book. And our goal was to really just lower that as much as we could and really aim for, if you've written any amount of code in a language, hopefully this book is approachable. It's not going to be perfectly understood by anyone who picks it up, but we just tried more and more, what can we strip out of this? And I think at the high water mark, the book was about 2.5 times as long as it ended up being in the final published version. And once we realized, we can remove this. We can remove this. And it became its own kind of addicting feeling of just like, oh, wow, we just removed 10 pages and the quality of the book did not drop at all. We didn't leave anything behind by doing that.
And I think this was a really good exercise because it helped us kind of strip down to, what is really the essence of this thing? And because there's so much, like when you wade into the documentation, you get all kinds of, it's this, it's that. And this process of saying, well, what can we take out and still have it be what it is really helped. And I mean, for me, I was just kind of hanging on by my fingernails the entire process. It wasn't until a year and a half or 2 years ago where lights started to come on and I started to maybe see, oh, maybe this is what we're doing. Maybe that is what we're doing. Oh, it was definitely a mental exercise and challenge.
Yeah. And it took us a while to get to the mission that we ultimately got to. Like we went through a number of iterations. At one point we were going to write a Scala 3 book, and then we were going to write a Scala Zio book. And then we came to effect-oriented programming, and we're like, the mission that we have is to teach people the value of effects, why they should use them, why they're better than what you're currently doing, how they help you create more reliable, testable software, more composable software. And so then that became the driving mission of the book, was let's teach people effects. And Scala and Zio just became a vehicle to do that. And then it became very easy to kind of decide what goes in the book. Is this helping people understand effects and the concepts of effects? Not Zio. Like, we're not going to teach you how to use Zio. Like, you can go learn that, read the documentation, read other books, but we want to teach you the concepts of effects and how they're going to benefit you in your code.
Yeah, nice. I mean, and this is just to give props to my editor. So I like what you've just said. My editor used to summarize by saying, it's important, Andrew, but is it essential? And I obviously didn't spend enough time trying to find the essential, but I like, to anyone who's listening to this who thinks, is this book worth reading? Like, in my, like, the fact that you like super succeeded in distilling it down to that kind of thing, it's not suspended on its own that it doesn't kind of apply to the real world, but it's very, you could find the stuff that's underpinning it if you wanted to, but you don't need to. It's very pure. And so that's leads, sorry.
I heard some evidence of this working. So there's a new AI framework that the Kotlin JetBrains folks came up with. And they actually I ran into them last week at DevOps, and they told me that their design for how they designed the like workflow definition system within this Kug AI thing was actually inspired by effect-oriented programming, and that they wanted to isolate the side effecting pieces from the workflow definition. And so I was like, cool, like that's like a totally different realm from what we were in when we wrote the book, but it inspired somebody to like take an effect-oriented approach to designing this library, which was really cool to hear.
I'm going to have to ask you more about that later.
Yeah, that's like, so my next question is just because we've teased this enough. So what are effects? This is the thing, right? So I thought I knew what they were, but I didn't. But now I do because I read the book. But for people who are interested in this, what are effects really? What are the, if you can distill your very terse book into an even shorter, quick explanation.
Yes. Okay. My current way of thinking about it is that effects are operations that can be composed. So we talk about composition with object-oriented programming. We stick objects together, but these rather than objects, these are operations, and you can compose them. And when you do, you get a new operation that can be composed. So it's kind of a holy grail sort of thing that we've been chasing throughout computer science from the beginning. How do we make bigger pieces out of smaller pieces? And the challenge here has been predominantly how side effects mess things up when you try and do composition. Eventually, it's a little easier, but then eventually side effects come in and make it harder and require the programmer to do lots of repetitive custom work every time they want to make these changes.
And I want to jump in and make sure we emphasize that it has an effect on the real world. It is something that operates outside of the realm of your processor, because if you're adding two numbers, sure, that's an operation that composes. But if you are adding two numbers and then sending a message about that to another system, okay, well, now the situation has fundamentally changed. You had an effect on the outside world, and that just brings new types of risk and consequences to these things. I think one important part is an effect can't be just universally undone. Once you have sent a message out into the world, that you have kicked off, the butterfly has flapped its wings, you don't know what is going to come out of that. So that's why you need to treat these things with special care, is because it can just cascade out into all these unexpected places. And so effects, you want to be very deliberate about when and how you execute them.
Right. You can't, when the way Bill described it, you've got all this stuff going on the outside. That's what makes it hard to compose these operations. So the effect has to encapsulate its own side effects so that it keeps track of everything. And that's what makes the composition possible.
And I think it's just the difference in, okay, this code puts something in a database, or this code, when it is executed, will put something in the database. And just that slight shift of, okay, well, now we have something that we can execute, or we can manipulate it further. We can clamp it down more. We can add some new behavior to it. Just the fact that it is not executed in a unprincipled way. You always have to be very deliberate about when is this going to be acted upon. And that deferred execution is pretty fundamental to empowering you to compose and alter the behavior in all sorts of arbitrary ways.
Yeah, because that was something that struck me was when as all three of you definitely know, I spent many years struggling trying to understand and wrap my head around functional programming. And because lots of my world was the kind of the side effects bit, which when you do FP, like core FP, they're like, don't worry about that. That's like, they're bad. We don't think about these. And I was like, but everything I do is side effects. But then, like you said, kind of Bill, right? Then this is extending kind of types and some kind of determinism into the world, the non-deterministic world of all of this unpredictable stuff, right? Like you said, when the butterfly flaps its wings. But I really
like giving you the right handles to manage the
100%.
Unpredictability of what happens once you talk to the outside world. So it doesn't it doesn't turn the unpredictable into predictable, but it gives you the tools to manage the unpredictable pieces. So you can easily put on like a timeout or a retry or these different things that you're like, okay, this thing may go wrong. I may get an error, which is unlikely to happen if I have a pure function. But I'm now things can go a different way than I expect them to. How do I deal with that? And then how do I deal with that at a single level or at the composed level of things? Because how do you every time you've got one unpredictable piece, you put them all together. Now you seem to have something very large and unpredictable, more unpredictableness. And so like, how do you deal with that at the small and at the big and use the same foundational pieces to do that?
And this was the thing, because this is what kept striking me again after having spent, time sitting in open space sessions with all three of you. Like you kept saying the compiler can check this. And I was like, this is a big deal, right? Like suddenly a lot more, like you said, you're not making the non-deterministic deterministic, but you can check that you thought about these things and that they compose together. And I think is that maybe the aha? Sorry, Bill, is that feels to me like one of the big things, right? That you want to get across.
Just all the things the compiler can do for you. In ZO, the particular effect system we're using for this book, as you execute a series of operations, if they have different failure modes, those all are tracked and assembled at the end. So if you have something that can time out here or have a network failure here, and you say, I want to call all of these things, at the end, you will get an effect that can fail with either that timeout exception or the network exception. And so you can choose, all right, do we want to handle these errors right now? Or do we just want to pass that information along and say, someone further up the chain is going to act on this? And
either way, they have to be dealt with. The compiler won't let you actually ignore, unintentionally ignore those.
Yeah. So when you are actually going to execute this, if you have not handled your errors, you have to explicitly call something like or die. And it's an evocative term, and it's saying, well, there's errors that you haven't handled. So if you are intent on running this right now, you have to say, I just want this to blow up if I haven't handled the errors. And it forces your hand at every point to say, hey, you are making a choice here. You might not have realized it in a different style of programming, but if you're ignoring your errors, you have to tell in the code, we are choosing to ignore the errors here. And then on the flip side, the compiler can also tell you, hey, you are trying to handle an error that can't happen in your code. And so getting that, in the first case, it's like, man, the compiler is really annoying here, like forcing me to handle these errors. But it can also really help you on the other side of saying, hey, you're being too defensive in your code here. Like you're trying to handle an error that can't actually happen here. And the compiler is going to yell at you for that as well.
Yeah. Like this is the thing. This is why it is one of these books where there's so much in it. Like I think I probably need to read it again actually because of the number of things, which even the stuff that you're mentioning now, which I'd kind of thought about but not really deeply thought about. One of the things, it comes from a functional heritage, but does it need to be like how much? Like you already kind of mentioned that the Kotlin team are doing things with it, James.
Not with this particular technology, but in the effect-oriented kind of way.
Yeah. Is there like? And I guess, Bruce, with your kind of heritage of like a long time across many different types of languages and type systems and all of that kind of things, do you like, because felt to me like it could be very applicable in lots of different ways, but do you think there's any kind of ways that we might be more, because obviously the Scala community are well aware of Zio and all this kind of stuff, but
I think we're starting to see a much broader kind of gravity towards effect-oriented programming. And the Kotlin Kug example was one, but in the TypeScript community, they already have essentially a port of Scala Zio to TypeScript, and it's gaining really rapid traction. We're actually working on a new version of our book that'll use that. And yeah, for people that want to use TypeScript instead of Scala, I think that'll be helpful. But so we're seeing kind of other ecosystems adopting the concepts of effect-oriented programming even in different ways. So while the TypeScript effect one was kind of Zio oriented, there's now a number of new modern, like very new emerging languages that build effects into the programming language. And so Unison is one. And then Rock is another one from Richard Feldman. Mm-hmm. And so when you build it into the language, you generally take a bit different of an approach. You do something called, there's algebraic effects, which is a different way to model effects, but all the core concepts are the same. It's just in the language, the way that you express the effects is a bit different. So yeah, I think we're seeing like it emerging into other ecosystems as well. We haven't seen it in Python yet, but hopefully we'll get there, because
it's a matter of time.
Well,
Python 4.
And you need a reliable type system to pull this off. And Python is kind of in the process of moving to, it's all optional typing, but I guess you could argue that about JavaScript as well. I mean, using TypeScript is an option, but I have high hopes, because Python's type system seems to reflect the things that Scala brought in much more effectively, I think, than, say, for example, TypeScript, which is an interesting challenge for us.
Yeah, I was being rude about TypeScript only yesterday, so I feel mildly guilty.
I do think that type system is maybe the most important piece to being able to manage effects in your language, because in Zio, there are 3 important types in any given effect. There is the output type. That's the one we're all comfortable with. That is what you expect to get out of your function. There are the failure types, which can accumulate. And then there's also, what do you need from the environment in order to run? And that's what the runtime handles for you. So stuff like a clock is one of the more basic ones. And if you do anything that needs to check timing, then your effect needs a clock. And being able to say, okay, we need a clock here. So when you're running this code for real, it's going to be the system clock. But if you just want to test this code, all right, we're going to give you a test clock, and now you're going to be able to manipulate that however you want. You can imitate something that runs over the course of a week, but do it in a unit test in a couple of milliseconds. And if you need something that uses random numbers, okay, we're going to give you some canned random numbers to make sure your code responds correctly, rather than we're going to use actual random numbers, which might make this thing take forever.
And hope that the bad ones will show up.
Yeah. And because your type system has codified, okay, here's where you are going outside of the processor. This is where you're interacting with the real world. That means, okay, you can track those types and put in the test versions that behave exactly as you want. So it is just, it's really empowered the types of tests that I write of. Mm-hmm. Like, okay, this wouldn't have been feasible to write a test for in a more primitive programming style, but now I feel like I can really test almost anything that is important to my code.
Yeah. One of the things that we've run into is there is a way to look at an effect system, which is really easy and obvious, which is, oh, now we're not going to throw exceptions anymore. Instead, we're going to package them into the result type. And people get that fairly easily and don't see the big picture. And so another example of the big picture is provisioning resources, which every program needs to do to some degree or another. And it involves a lot of fiddly work on the part of the programmer. And it's not really, a good use of programmer time, because it's all, it's all this messy stuff that they have to do. And, is there a way that we could automate that? Because, one resource might depend on another, et cetera, and you have to work all that out every time. And so an effects system, because it keeps track of all these things, can do that for you. And so that, you're not wasting a bunch of time. And if you have to change it, you don't have to redesign everything. So the big picture is that it's reducing the kinds of fiddly stuff that programmers have just gotten used to doing on every application, and instead allowing you to focus on what is it that this program needs to accomplish, and not all the edge details of how.
Yeah, you can just express in your types, I need these things in order to execute. And the runtime will make sure that you have those things available to you. And it's another chance for the compiler to tell you, we're not even going to try to execute your code because you said you need this particular service and that is not available. And
this is what I thought, again, it's very clear in the book, that, and the simplicity of that kind of the conceptual model that you just explained, Bill, right? It is very simple. And then you then build it up in lots of different ways and show you how it can work. And I think, I'm not sure you actually take a pot shot at Spring, but Spring kind of brought these pieces together, right? But they were it's outside the compiler and good luck figuring this stuff out at runtime. And then it all magically, it felt just like you've all kind of said, it's making more stuff explicit. So you specify it and then you talk about it and you need to define it, et cetera, et cetera. And then, because this is work of programming, right? It's stuff you need to do, but it's just, we'd write the code and then we do the extra stuff. And the extra stuff would frequently be where the bits would break. But now, because it's in code, we can test it.
And it's just in normal code rather than
exactly
configurations.
Exactly. Which is where you spend half your life in Spring. Or I have. I'm old enough to remember doing. Probably kids don't do Spring anymore. But whatever kids are doing, back in the day, you'd spend days trying to figure out what was actually happening in the Spring container after you kind of defined it in code, and then hopefully annotated your way into something that worked, and then it would just
right. You'd have a 5-line function and then 6 lines of annotations above it, which is somehow going to connect everything up.
Yeah, magic.
Allegedly. And with ZO and these languages that put effects first, it all feels like writing normal code of, okay, it's a more advanced return type from our function, but it is just a function that returns something. Yes. And it's not, this thing throws an exception. So that's a new bit of syntax that you have to handle completely differently. No, that's just one more result that it can give you. And you find yourself writing code in a style that's just, we're calling more methods on these types here. We're not reaching out for this totally different code style here with a flow that no one really has a full model of. It's just
precisely
normal code.
There is some similarities to what was in the advent of Spring called aspect-oriented programming.
I'm old enough to remember that too.
A way to drive this. I don't know. I may need to do things before or after some bit of logic that I write happen, whether it's open a database connection, or if I got an error, do some special thing. And so the annotation approach to AOP was what Spring embraced. But as we've said, that's not represented in the type system. It's a different kind of meta-programming model that then weaves all together into defining these structures and this logic. And in effect-oriented programming, We just model all that as a data type, which is an effect. And so it's great for testability, having the compiler check things.
And it's fascinating to, kind of look back and say, oh, EJBs and Spring and aspects and all those things were attempts to solve this problem that 100%. We could see. All we could see was, programming is getting harder and harder. And what this is kind of bringing it in and I don't know, giving it a mathematical foundation so we can say, oh, yes, we're really covering all the bases here rather than kind of taking pot shots at, maybe this will work, maybe this will work, maybe this will simplify things.
And it's got a mathematical foundation, but doesn't require you to understand the math.
Yeah, this was the best bit because I like famously had to learn math because I couldn't to get my head around FP, and it turned out that which was useful, but like
you only know that in hindsight because initially the frustrating thing is realizing how bad we are at explaining this stuff because we get lost in the wrong details. And so saying, to understand FB or effects or whatever, you need to understand what's the monad laws or something. All this stuff. And then finally you sort of start to grasp it and you go, well, no, you don't. We just, the people who pioneered this, that's how they came to understand it. So that's how they explained it to us. And we're just sitting here scratching our heads going, but how does it actually work? What problem is it actually solving?
It turns out that when we're building effects with something like Zio that's monadic oriented based on a monad, we really benefit because a monad has mathematical laws that it obeys. But as a user of an effect system that's based on monads, you don't even need to know what a monad is. And so we actually very intentionally in the book have a list of forbidden words that we do not.
I was going to say monad is nowhere in this book.
If we say the word monad in prose or in funct or like we've got all these like functional programming terms that we intentionally avoided because we didn't want people to get lost in the terminology. Because we really do think that you can understand effects without having to know the foundations of functional programming and math and, the laws behind monads and associativity and all those things.
Yeah, exactly.
Yeah, circling back to just keeping our book small and, very focused was it, it was always a moment that we could high five each other when we added a new word to that forbidden word list. It was, yes. We can drop this and we can still cover everything we want to without subjecting the reader to that scary word that has probably scarred them in the past or would alienate them and keep them from actually getting through the book. So
just 100%.
And just knowing, and we can't slip up here. The book will not publish if we accidentally drop this word in here.
Well, and I think all of our return types were inferred. So we never actually saw the signature of the return type.
Zio, the data type that we use everywhere, is actually in our forbidden words. So we cannot actually put the Zio data type into any of our code examples.
Because my experience was these guys were going, so look, it returns this thing. And I'm looking at this thing and I'm going, that's too much. It's not helpful. I don't know what's going on. And so eventually we banned that. And it's way easier to understand, I think.
So this is actually my last question, actually, which might lead into, so this writing a book on my own is hard enough, but I can't imagine how 3 people could come together and write a book. And yet, it reads like the consistency and the kind of conceptuality of your book is incredibly, it works. So do you want to maybe just as a kind of closing thoughts for all 3 of you, like you've already started talking about it, but that is super interesting to me, how you managed to make something so coherent when it's literally 3 people from very different backgrounds.
In person. Like most of the book has been built with the 3 of us sitting in Bill's living room working on it together in the evenings. And so I think that is a big part of it. Like we didn't do things like, okay, you do this chapter and you do this chapter. Like it was all a collaboration.
Yeah. We might break off and write a few paragraphs on our own and then kind of bring that up for further discussion. That happened in small chunks. And again, it's a small book, and it's a lot easier to maintain a consistent style over 100 pages rather than 500 pages of, I forgot we even wrote this chapter. And yeah, I think just keeping it small really helped us in so many ways. And just maybe one other thing I wanted to just touch on is, as far as keeping things concise and small, is you can read the entire book in portrait mode on your phone.
Oh yeah, Bill was,
which I did, by the way.
Wanted that.
Yeah, so I can guarantee that it's possible, because that's why I did it.
Yeah, and that, only having lines that have to be 47 characters or less seems insane. When we first made that decision of, okay, we're going to enforce that in our CI, and it caused a fair amount of pain through the process of, okay, we want to show this, but we can't really do it in 47 characters or less. And that just pushed us again to, okay, make it simpler. And if our variable name is too long and we can't fit it, figure out a way
we even need
to
the
write
variable.
Yes.
Need a name.
Yeah.
And that just kind of kept us focused and let us keep things as simple as we could figure out. I won't try to claim that it is maximally simple, but it is.
I'm very oriented to effect-oriented programming. It's like, is this about teaching people effects? Yeah.
There's a quote by Orson Welles, something to the effect of, art without constraints is chaos, or something to that effect. So we have a lot of constraints.
And it's totally worked. Like, just to close down, I would definitely recommend, I obviously think everyone should because I'm hosting this, but it's a very interesting topic. I think it's very important, it's not about ZIO, right? It's about effect-oriented programming. I think it feels to me like it's a real thing that will have a big impact. And I think this book is it's not just an introduction. It's the kind of thing you could read multiple times and get more of. So all of the effort that you three of you put into it, I think is you can see it. You can definitely see it on the page, and you can read it on your phone.
I think effects may be the next fundamental shift in programming because of the wall that we've been running up against for the last 20 or 30 years.
I agree. But that's a great thing to finish on, actually. So thanks all three of you for joining me, and thanks for taking part in another edition of the GOTO Book Club. Cheers, everyone.
Yeah, it's great.
Thanks for listening to this episode of the GOTO Podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.